So now we'll do some debugging for the add to rear method. Actually, the add to front method. So we'll start where we'll continue with the add to front method. So we have 5. Actually, we'll add 6 here, and then we'll add we'll call unordered list. We'll add to the front, and we'll add 5 to the front. We'll move our breakpoint down here, and then we'll click debug. So we can see our list here, it just has 6 in it. Has the element 6 at memory location 985. So we'll step into that one. So if size is equal to list length, so rear is not equal to 5. So it'll skip. Now we'll do the shifting again. So for int scan equals to 1, scan is greater than 0, scan minus minus, list of index scan. So we'll step in. Scan is equal to 1, you can see here. Scan is greater than 0, scan minus minus, so I think it's only going to iterate once to keep this condition true. So list of index 1. So let's see our list here of index 1 points to list of scan minus 1. So list of index 1, list of array index 1 points to list of scan minus 1, which is 0. 1 minus 1 is 0. So I'll just do the note here. List of 0, actually sorry, list of 1 points to list of 1 minus 1, which is 0. So list of 1 points to list of 0. So if we have our list here, we have index 0 equals index 0 equals 6, and index 1 equals a null. Then we'll say list of array index 1, which is this one, points to list of index 0, which is this one, so it'll get swapped or shifted. So it equals to 6. Then it'll come back to the condition. The condition will be false because scan is equal to 1. Actually no, sorry, a scan minus minus, so scan is equal to 0. So scan is equal to 0, scan is greater than 0, is 0 greater than 0? No, it's false, so it'll skip to here. So list of 0 points to the element, which is 5, that we're trying to add. So you can see our list here was updated. Index 0 equals to 5 and index 1 equals to 6. Then rear plus plus. Rear will become 2. Mod count plus plus, mod count will become 2. And done. So we'll test this one. Add after. So we do have, no, that's okay. So we'll say we'll add 11 after 6, something like that. So it takes a T element, the element to be added after the target element. So here we'll say unordered, I'll just type it, unordered list dot add after it takes an element to add. We'll add 11 after the element 6, the target 6. We'll move our breakpoint here and then we'll start debugging. Actually, we'll stop debugging first. Then click debug again. So we can check our list to see we have 5 and 6. We'll step in. So our element is 11, our target is 6. If size is equal to list length, that's false. Int scan is equal to 0. Wall scan. So wall scan is less than rear. So scan is equal to 0, so 0 is less than 2. And target, which is 6, does not equal list of scan, a list of index scan. Scan plus plus, so while 0 is less than 2. And target, which is 11, so while 11 does not equal list of scan, sorry, our target is 6, so while 6 does not equal list of scan, scan plus plus, so it's going to shift up. So scan is 0 and our list is 5 for index 0, so it's not going to equal scan plus plus. So now scan is 1. While scan is less than rear. So while 1 is less than 2 and 6 does not equal list of 1, list of array index 1. Well, it does. So it's going to skip to this line. If scan is equal to rear, so if 1 is equal to 2, is 1 equal to 2? That's false, so it's going to skip to here, scan plus plus. So then we'll execute it to scan plus plus. Scan becomes 2. For int shift equals to rear. So again, we're going to shift the elements up 1. Backwards, instead of using scan, we're calling it shift. You can use I again, it's easier, or J, if you're used to it. But also it's good to practice with different keywords just to train your brain to work the same as I and J. So we'll say for int shift equals to 2. Shift is greater than 2. I guess scan is 2, so int shift points to rear, so shift is 2. Shift, so 2 is greater than 2. It's actually, we're adding after 6. So I think that's false because shift is equal to 2. Is 2 greater than 2? It's not, so it should skip here. So it was skipped because the condition is because 2 is not greater than 2. If it was greater than equal, then it would have been true. But it was false, so it skipped here. Then we'll insert the element. So we'll say we're inserting the element 11. So list of index scan, which is 2, 0, 1, 2, will become 11. Now we have 11, and then rear plus plus, rear will become 3, mod count plus plus, mod count will become 3. So that one's finished. We'll print it too. We can click console and see what's printed here. You can also we can also print it left to right. That probably would have been better. Then we'll stop. So this one's done. Can we test some of these in the general methods for all array lists? So we're not going to do remove. Actually, we're not going to do any iterators right now. We'll do that in the next video. ToString we know, it's just printing it out. We can change the new line to a space. We'll run it, and we'll see these get printed out left to right. Now it looks better because it's an array list, not a stack. So that's fine. Size we know. It should print 3. Is empty. We know that. We can test find and we can test contains. Last we know, first we know. And then we'll have to remove them as well. So let's test find. Find. So contains does use find. It's a private method, so we can call it again on an object. So we can use this one. So we can say, does the list contain 6? Move your breakpoint and then click debug. We have our list here, we can see we have 5, 6, 11. We'll step in. So contains returns find with the parameter target that we passed in contains. So returns true if find param target does not equal to not found. So if it does not equal to -1, we'll step in. So target 6. Scan points to 0. Result points to -1. While result equals to not found. So while result is equal to -1 and scan is less than rear. So we're here now. We'll skip that because what happened here? Did I make a mistake here? I shouldn't have skipped that line. I think this should say if not is empty. I'll just double check my notes, sorry. I might have made a mistake when I wrote the code. Unless there's a mistake in the textbook itself or the... Yeah, I think it is. This code might be from a textbook. So this is ArrayList generic type T. And this is the find method. So I have it right here. Yeah, that should be a not. So we'll add a not there. You can change it if you haven't already. And then we'll just continue. We'll re-debug. We'll stop it. Then we'll run it again. We'll step in. We'll step in. Step in. Step in. Step in. So while result. So while -1 is equal to not found, which is -1, because result points to -1 here, not found. And scan is less than rear, scan is less than 3, that's true, we'll step in. If target is 6, dot equals list of index scan, which is 0. Result points to scan, which would be 0, but it's not, because 6 does not equal list of array index scan, which is list of 0. So 6, so this is false, because 6, so it's asking it, does 6 equal list of array index 0? Well, does 6 equal 5? No, it does not. So it's going to skip to else. So else, then scan plus plus, scan becomes 1. So we add 1. So while result is equal to -1, which is still true, and scan, which is -1, is less than 3, that's also true. Step in. If target dot equals, so target, which is 6, equals list of scan, which is 1, or array index scan, which is 1. So list of array index scan, index 1 points to 6. It's true, so result is going to point to scan, which is 1. So result will change to 1. It should change. Result changes to 1. The condition finished, and it pretend there's a bracket here. There's not, that's why I like to put them. But then it just loops back up to the condition. So while result is equal to -1, that's false, so immediately this whole block will get skipped to here. That's why I like the brackets, to help me see quickly, or else I have to check how many lines it is. If this one was like 50 or even more 100,000 lines of a loop, then a bracket would help. Well, maybe not for 1,000, but if at least it's for like 10 to 20 lines, it could help. So this one should get skipped to here. Then we'll return result, which is 1. Returns true if find, so the method find of parameter target does not equal to -1. It's true because we returned 1 and not -1. So we should have, we can stop here and just put here, we can put system.out, system.out.println. We should get a true or false. We can take the breakpoint out, just run it, and it should say true here, above here. See, true, and same elements. So that one's done, and we also finished this one, so we did 2 methods in one. This one we don't need because it's pretty easy, just have to check one place, one location. We'll just remove. So usually you remove the last one. You don't have to, but this one takes an element or an object. of type T. This one is just remove the first element in the list, like the head. Remove head or remove first or front. And this is remove tail or remove rear, same thing. So we'll start with this, we'll start with this one, remove last. So we'll call our list here and say remove last. We'll put a breakpoint here and we'll run. So we'll step in. So if is empty, that's false. So we create a T result variable here. It's null right now. Then we'll decrement rear by 1, so it'll become 3 to 2. It'll become 2. 3 minus 1. Result points to list of index rear. Result points to 11. Then list of array index 2, 0, 1, 2 is set to null. Okay, so that's okay. That's good. Then, do we add this? We might have added this line. Maybe not. For list of array index rear, which is 2, because rear is 2, 0, 1, 2 is set to null. So that's good. And then mod count plus 1. Return result. So that one should be correct. And we can make it more efficient. It seems like it's most efficient right now. And we can check our list to see if it was updated. It was. We'll stop that. So we'll see, so we finish this one. We can do this one. So remove first. We can leave that for now, so we'll say unordered list. We'll start debugging. So we have our list, 5 and 6. We'll step in. This will get skipped to here. So T result points to list of array index 0. So result points to 5. Rear minus minus, so rear will become 1. For in scan is equal to 0, scan is less than rear. 0 is less than rear. 0 is less than 1. Scan plus plus. List of index 0 points to list of scan plus 1. So it's going to shift the elements to the left because scan is 0 plus 1 is 1. So list of index scan, which is 0, points to list of scan, which is 0 plus 1, which is 1. So list of array index scan, which is 0, will become a list of array index scan, which is 0, will become list of array index scan plus 1, which is 0 plus 1, so list of index 0 should become 6. Then we've incremented scan plus plus. So scan gets incremented by 1, so scan is now 1. Is 1 less than 1? It's not, so the condition's false. Now it's going to skip to here. So list of array index 1, 0, 1 points to null, so we're going to make this index null to delete the element, which is it's right. Then we'll mod count plus plus. Don't worry about this, we'll go over it in the next chapter. And then just remember, if these mod counts get out of sync, if they're not equal to the one in the iterator, then you'll get a concurrent modification exception, or the iterator will not work as expected. Then we'll return result. So we can see our list, how list just has, because we removed first, which was 5, and now we have 6. We have 6 in index 0. That's it. So we'll stop, and we'll just check if that was correct. Okay, we have 5 and 6. We removed first, which is 5. We were left with 6, so it was correct. Now we'll just do this one, remove, and then we're almost done with just do the last one, ordered list, just one method, and we're done. So after a 3-hour video or something, we're finally done. Again, you can choose to create a head reference if you like. It would just be always equal to index 0. It's up to you. Or you can just reference index 0, so it's just setting a pointer, nothing special. Rather than always saying list of index 0 equals, you can just say head equals, that's it. And if you really want to, you can set a middle reference to like 0 plus the length divided by 2 if you want. Or you can set special ones every 5 or 10, 2 elements. So now we'll just do the one method. Which one was it? Remove. Excuse me, so it's going to search for an element and remove it. So we'll take these out, or we'll comment it out because we want the whole list for now. So we have, just check, we should have 5, 6, 11. 5, 6, 11, so we'll call here unordered list. Dot remove, and we'll remove 6. And we'll set a breakpoint here and hit debug. So we have our elements here, objects. We'll step in. So T result is set to null. Int index points to find element. Find element. So we know the find method. It's in this one. So int index points to find element. So find, we just did it. It's this one. So it'll point to the index that it is. we can step over because we already know this one. So we'll just click here. Instead of step in, we'll step over. So we have the index is equal to 1 because it was in the first index here. If index is equal to not found, if 1 is equal to -1, that's false. So we'll skip this. You can step over as well. Then we'll say result points to list of index. Result points to list of index 1. Result points to 6. Rear decrements by 1. So 3 minus 1 equals 2. For in scan is equal to 1. 1 is less than 2. Scan plus plus. So we're removing removing 6. So we're saying scan is equal to index. So scan is equal to 1. 1 is less than 2. 1 plus plus, so list of array index 1. Points to list of scan plus 1. So scan is 1, 1 plus 1, list of, so that's list of array index 2. So 6 is going to get removed and 11 is going to get shifted over to index 1. Now we're going to, so now we're back up here. Scan plus plus. So scan is equal to 2. 2 is less than 2. Well, is 2 less than 2? It's not, so this condition is false. So we'll skip to here. So list of index 2 is set to null. So that 11 will get set to null. Then mod count plus plus. Mod count is set to 4. Then it's going to return 6. And you can see 6 was removed. So we're finished. So now we'll finish those methods, we just have one more. So for this one we'll have to create a new object. Ordered list. So we can, I'll just take this out. Then I'll comment all this out. So you can do that with control and then backslash. Then we'll say array ordered list. Let's just do a string here. Is set equal to new array ordered list of type object string. Array ordered list, whoops, we didn't name it. So I'll just say array ordered list of, ordered list of type string objects. We'll just call it ordered list is set equal to new array ordered list of type string object. And actually it does take a parameter, I think. We'll just say 5. It takes in a capacity, or it's going to use the default capacity, which is also 5. If you want to see how to use the overloaded constructor, just see one of the previous videos. I already did a demonstration on that using the this and the super constructor. So we'll call ordered list, and it has an add method. Actually, I'm not sure if we can do string because it's comparable. Actually, then we'll change it because it might make it complicated. So we'll just use integer. The wrapper class for int. So we'll say order list dot. We'll just check this one. So it's add. So we'll add a integer. We'll just add 5. Then we'll just add some more. We'll just add one more, 6. And then we'll just set a breakpoint here and debug. So we'll step in. So if element is not an instance of comparable, perhaps the number or integer class implements the comparable interface. So if element is an instance of comparable is not, so if element is not an instance of comparable, so it must be. I think before I actually created some comparable objects, I overrid the comparable method and I created an object and I actually implemented the comparable method to compare the objects. You can also do that if you want, but we'll just use the integer numbers. So then we'll cast. It might be unnecessary, this line, but it might just be just in case. So we'll say comparable of generic type D, comparable elements, so it's just an object reference here. Object reference variable points to element, which is casted to comparable of generic type T. So we'll just say comparable element points to element. You can see comparable element points to element. It has a memory location 956, and so does element. So if size is equal to list.length, that's false. So int scan is equal to 0. Now we're going to find the insertion point. So right now our list is empty. So I think it's going to just add it in order, so everything has an order, like a string has a Unicode ordering, a string has Unicode ordering, a number has less than or equal to based on just integer values. I think that's what's going to happen, so we'll say while scan is less than rear. So while 0 is less than 0, that's false, so we'll skip. So for int shift points to rear, so shift is equal to 0. Shift is equal to 0. Shift is greater than scan, so shift is equal to 0. Shift is greater than 0, so that should be also false. Skip. Then we'll say list of array index scan, which is 0 points to the element. So list of index 0 points to 5. Rear becomes 1. Mod count becomes 1. Then we'll step into this one. Skip. So just comparable element is going to point to element. Skip this one because it's false. Scan is equal to 0. Scan is less than rear, so 0 is less than 1. And comparable element dot compare to list of index scan, which is 0, is greater than 0. So while scan is less than 1, that's true, so 0 is less than 1, and comparable element, which is 6, dot compare to list of array index scan, which is 0, and comparable element, which is 6, dot compare to list, so compare to returns -1, 1, or 0, -1, 0, 1, usually. I think the default one does. So basically all it's saying is 6 dot compare to list of array index scan, which is 5. So 6 dot compare to 5 is greater than 0. That's true, so scan will become plus plus, so it'll become 1. So now we'll say scan is less than rear. Is 1 less than 1? No, it's not, it's false. So 1 is not less than 1, so we'll skip. So now we'll shift the elements up. So shift points to rear. Shift, so shift points, so shift is equal to 1. Shift is greater than scan, so is 1 greater than 1? Shift is equal to rear, which is 1. 1 is greater than 1. 1 is not greater than 1, so that's false. So list of array index scan points to element. List of array index 1 points to 6. Rear is 1 plus 1, so it becomes 2. Mod count is 1 plus 1, so it becomes 2. So that's it. That concludes the ArrayList implementation, and in the next video we'll do the linked list implementation. So I'll see you guys next time. Take care. Thanks.